e, which is a beautiful thing. Let's say it says k of t is equal to the square root of 2t plus 1. Now, we are trying to get the derivative by the definition. We know the first thing we do is we find k of t plus h, okay? We change whatever was inside, whether it was an x, whether it is whatever, we put the thingy when you added an h to it. So it's now t plus h. So now we change. So this is, instead of 2t, it's 2 of t plus h. Don't forget, 2 is affecting both now, t plus h, because where there was h, you're putting, then you say plus 1, then you put the square root outside. How beautiful is this? So now you're going to say now that the first derivative of this, of k of t, is going to be k of t plus h minus k of t, the original one, all over h. But you should say the limit as h goes to 0. That is our first derivative of t, okay? So that is k dash t. This is going to be equal to this, right? Now let's put those things, let's put them. So this is just going to be equal to the limit as h goes towards 0 of k of t plus h is going to be the square root of 2 of t plus h plus 1, okay? Plus 1. Then we say minus, what is k of t? Is the square root of, so it's minus the square root of 2t plus 1 all over h. And what is this going to give us? Well, when it's like this, of course, we see that we have these surds, right? We have these squares that we can't really evaluate. So what are we going to do? We are going to just multiply by the conjugate. But first, I could try to simplify this. We've worked through this before, so we know what it's supposed to do. So we can say that it's going to be the limit as h goes to 0 of the square root of 2t plus 2h plus 1 minus the square root of 2t plus 1 all over h. Because we can't substitute h, so the only way is to then multiply by the conjugate. So we're going to say that this is going to be equal to the limit as h goes to 0 of the square root of 2t plus 2h plus 1 minus the square root of 2t plus 1, okay, over h. And this is going to multiply the square root of 2t plus 2h plus 1 plus conjugate, you change the sign, the square root of 2t plus the square root of 2t plus 1. And it's all over the same thing, the square root of 2t plus 2h plus 1 plus the square root of 2t plus 1. Now this is going to be this. Then we say, then it's going to be equal to, now we say equal to the limit as h goes towards 0 of. Now what happens? The top is very easy. Conjugate, we know what we do. We square the first term, we put a minus, we square the last. So what do you do when you square the first term? The square root goes 2t plus 2h plus 1 minus, now we square the second thing, which is going to just be 2t plus 1 because the square root sign will go. Then it is going to be all over h is going to multiply this thing, which is going to be the square root of 2t plus 2h plus 1 plus the square root of 2t plus 1, right? So, and this is the limit as h goes to 0. So let's do this. Now, what are we going to have here? We're going to have the limit as h goes to 0 of 2t plus 2h plus 1 minus 2t times minus of 2t, then minus of plus 1 becomes minus of 1 all over h multiplying the square root of 2t plus 2h plus 1 plus the square root of 2t plus 1. Okay, so then what happens here is, of course, we're going to have 2t cancel with this, we're going to have 1 cancel with this, then we're just going to have the limit as h goes to 0 of 2h all over h multiplying the square root of 2t plus 2h plus 1 plus the square root of 2t plus 1, like this. H will cancel with h, okay, and we have the limit as h goes to 0 of 2 all over the square root. Now, that is what we are now doing. We say the square root of 2t plus 2h plus 1 plus the square root again of 2t plus 1. And we have eliminated the problem. So now what do we have here? We substitute. Wherever there's h, we're now putting 0. So it's now, because we no longer have the denominator going towards 0, it's now 2 over the square root of 2t plus 2 by 0, then plus 1, okay? Then plus again the square root of, now this is just 2t plus 1. And what does this become? 2 over, now what do we have? The square root of 2 by 0 is obviously a 0, so this would be 2t plus 1, okay, plus the square root again of 2t plus 1. So now we have 2 of them, so it's going to be 2 over 2 of the square root of 2t plus 1, because we are adding this to this, it becomes 2 of them. And we say 2 into 2, 1 into here, it's 1. Remember to do it with a pencil. You now have 1 over the square root of 2t plus 1. This is going to be our final solution for this, okay? We have found the derivative. Now we can say that k prime, we can say that k prime of t is going to be 1 over the square root of 2t plus 1, okay? Now that we have it, we can continue. And now that we have it, makes it very simple for us. We say k prime of 0, that means wherever there's t, we are putting 0. It'll be 1 over the square root of 2 by 0 plus 1, which is going to be 1 over the square root of 1. And this is just going to be 1. Now we can say k prime of 1 is now going to be 1 over, can skip lines. It's going to be 1 over the square root of 2 by 1 plus 1, which is going to be 1 over the square root of 2 plus 1, which is equal to 1 over root 3. Now we can say k prime of 2, this is going to be 1 over square root of 2 by 2 plus 1, which is going to be equal to 1 over 2 by 2 is 4 plus 1 is 5. So it's 1 over root 5, okay? And this is what we have, 1 over root 5. So this is going to be our final solution. We've done very well. We've done the whole of number 1. We go to number 2. Well done, well done, well done.